The data VLAN it's dedicated to user traffic, such as web browsing and email transmission, for example. Okay, so data is for email and web, for example. VLAN 1, which is the default data, it's the default data VLAN. Why? Because here, as you see, all the interfaces are assigned to this VLAN initially. Okay? Whenever you start with the switch, you will see all these ports are assigned to VLAN 1. So VLAN 1 is a data, okay, data VLAN, because all interfaces are assigned to this LAN. However, native VLAN, it's another. This is used for trunk links only. Trunk, when we use trunk link, okay, it means that there is tags, some tags on the frames. So within this trunk link, if we have any VLAN that doesn't use tags, we call this VLAN is native. But in any trunk link, we only have one native link, one native VLAN. Okay? So all frames are tagged on an A2.1Q trunk link. All frames are tagged. They are tagged, all of them, except for those on the native VLAN. So if we have trunk link and we have one LAN which doesn't use tagging, we call this VLAN is native. So native, it's only on trunk links. VLAN doesn't depend on, it's independent. Management VLAN, whenever we want to use network management features like SSH or Telnet VTY traffic, we will have management LAN. So the VLAN, which is for management, it's usually the SVI for layer 2 switch, as we did in the beginning, at the beginning of this course. So data LANs, data VLANs, native VLANs, management VLANs. So here I added this just to clarify some stuff for you. I added it. So the native VLAN is the VLAN on a trunk. It's on trunk always, whose traffic is sent without a VLAN tag, untagged traffic, when using IEEE 802.1Q. So native VLAN, it's the default VLAN for any frame that doesn't carry a tag. And we use tag on what? On trunk link. So native is the default on the trunk that doesn't carry a tag. When a frame belongs to the native VLAN, it means it's sent without tag. Okay? When the receiving switch gets an untagged frame, it assumes it belongs to the native VLAN. However, trunk link is between two switches. Native VLAN equals to VLAN 1 if a frame arrives. Untagged frames are assigned to VLAN 1. Okay? And if tagged, for example, are assigned to VLAN 10, for example. Okay? Okay, so default native VLAN is usually VLAN 1. And it should be, it must be the same on both sides of the string, this interface and this interface. And this is very important. Only one native VLAN, as I mentioned earlier. So one native VLAN per trunk. used for untagged traffic. So native VLAN it equals the VLAN used for untagged traffic on a trunk. Default native VLAN it's the VLAN 1. Okay, it's the default native. So native VLAN it's any VLAN used untagged traffic on a trunk. However, default native VLAN it's the VLAN 1. We are continued. Now voice VLAN. What's the voice? Imagine that we have a trunk, or let's continue on the course normally. So it's a separate VLAN is required because voice traffic required. So it's a VLAN. We need this voice VLAN in order um, to 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 transmit to communicate voice traffic, which as you know the voice traffic needs high quality of service priority if with web or with other things, and it should avoid congestion because we need enough bandwidth, and we need this delay for the voice, at least this delay from source to destinations for the voice service. So to do to make a VLAN for voice, we need to design entirely the network to support this voice service. What's going on here? Imagine that this is switch, for example, and this interface S3 connects S3 connects with the IP and with PC5. This is student VLAN 20, and this is IP telephone. Okay, telephone voice over IP, and here we have this switched here. Switch configured to support voice traffic here. Uses VLAN 150 for voice VLAN. This one, for example, prioritizes voice traffic here because there's quality of service. So you have to differentiate your traffic here. However, here switch 3, switch port configured to support voice traffic because for sure we need to, because the router is here, we will have this traffic, this traffic, this traffic. We should transmit voice and transmit data. So port sends CDP frames to provide information used by the IP for sure. Port here, this port forwards frames associated with VLAN VLAN 50 also. Okay. VLAN in a multi-switched environment. This is an example here. So first of all, we have to define the trunk. What's a trunk? Trunk, it's a link, point-to-point link between two network devices like S1, S2 trunk, S1, S3 trunk, this one. So a trunk is a point-to-point link between two networks. A trunk is a network link, port or connection that carries traffic from multiple VLANs at the same time. The most important thing is that the trunk here carries multiple carries traffic from multiple VLANs. VLAN 10, VLAN 20, VLAN 30, they communicate. They all of them pass through this link. Okay, and here also the same thing. So Cisco trunk functions. What are the Cisco trunk functions? Allow more than one VLAN to pass through the trunk. This means to pass through this trunk, it allow more than one VLAN traffic here. extend the VLAN across the entire network. For sure, it extends. Why it extends? Because it passes the traffic for different VLANs, from VLAN 10 to VLAN 2 here to VLAN 10 to VLAN 3. As you see, instead of assume that we don't have here these VLANs here, we have only these VLANs here. So we have extended these VLANs by using trunction. We have added these here, right? So it's about the extension of the network. So trunction or VLAN trunks extend the network. Okay. By default, uh, it supports all the LAN. We can do trunks for all VLANs, and also these functions, trunk functions, support the 802.1q trunction or trunking because of the tagging. Okay. As you see here, as I told the previous, the student here and the student here, they are logically connected, and guest logically connected, faculty guest connected, even though they are far away at 1 hop, 2 hop, 3 hop, 4 hop, 4 hop, 4 hop. Okay. So without the VLANs, for example, imagine that we don't have VLANs. We have these networks like that. Student, faculty, guest, student, faculty. We don't have VLANs. All devices connected to the switch will receive all the unicast, the broadcast and the multicast traffic. So it means that because VLANs makes the traffic isolated for specific type of VLANs, right? Here, whenever the switch will receive a broadcast or unicast or multicast, it will flood all this traffic here, here, and here. So it doesn't differentiate between student, guest, faculty. However, if we use VLANs here, no, the traffic will be specific. So this, if it's a trunk here or configured as a trunk, so the switch will transmit the broadcast for the faculty, but not for the student. And also here, so because it differentiates the frames based on some